My name's Eric. I'm a chief architect at SSW. I've been working here for over 10 years now, so I've seen my fair share of applications and had to tune a whole bunch of applications as well. So a lot of the stuff that I'll be talking about tonight, I've experienced. It's bitten me in the butt, and hopefully it'll help you guys when you need to do some performance tuning. All right. So we were engaged by a large retailer. They had problems with their existing shopping site. It was old, outdated, running classic ASP. And basically when they had big sales events, the site kept crashing. So obviously they were losing money that way. The volume starts increasing in the lead up to Christmas as people shop for their Christmas presents. They have a physical shop as well as the website. And they close for a brief period after Christmas. And they reopen in January where they have a really massive sale. And that's often when the website just is not responsive at all. Okay, so SSW was engaged to basically update their application to a later version of their third-party e-commerce platform. And obviously develop a few new features as well, like gift registry, gift cards, integrate with their inventory tracking system, things like that. And obviously the most important one was ensure that their site stays up during the sales. Okay, so we went on, developed. As January approaches, we get ready for the big sale. Get ready to go live with this new application. So before that, we had a sprint just focused on performance. Okay, so we set up the MS web tests, we ran load tests, and then we optimized and sort of just did what we could to make sure that the website was, could perform up to expectations. So here's an example of the web tests we set up. It's fairly simple. You can see the actions down the bottom. We looked at shopping cart. We added some items to the shopping cart. We searched for some items. We ran this test for against 50 users, and we got a response time of about 7 seconds per page, which is quite slow, right? To be honest. Okay, so we went ahead and started tweaking the performance. We ran like profilers, ran SQL Profiler. We added caching to the application. Got it a bit better. So this time we're running 100 users and we're getting average page response time of about 5 seconds. So the client was happy with that. Obviously in today's standard, that's like really bad. You want like sub-second ones, but back then that was pretty good for a big site like this. So client gave us the go-ahead, send it live, and guess what happened? Yeah. All right, so we had to roll back. Their old site still didn't perform, but didn't want to deal with the problems with the new site as well. So they had to restart IS constantly, and basically they're in the same position they were last year. Okay, but now that we've missed this big sale date, we've got a little bit more breathing room where we can sort of dig deeper, find out what was actually causing the problems. Okay, we're not working to that deadline. So in the post-mortem, we concluded that the test that we set up didn't actually reflect how users were actually going to use the site. Our test cases were a bit simplistic. Okay, and we also found that they were analyzing the logs, that there were actually a lot more users hitting the site than what the client told us. Okay, and the tests that we were running on those MS web tests were against our local development environment, and they weren't actually running on the production environment. All right, so we went on this journey, tried to, number one, fix the test so that they more accurately represented how users were going to use the site, so that we could at least replicate the issue that we saw on that sale date. Okay, then we tried to identify what the bottlenecks were, go ahead and optimize, develop. Okay, so fixing the tests. So the client set up a new goal that, all right, so looking at the logs, we're getting about 1,000 sort of active sessions. So let's plan ahead for the future. We want the new goal to be 4,000 concurrent users using the site. So we're going to set up the tests to start at 200 users hitting the site, ramp it up to 5,000. Okay, and then hopefully we'll see that test fail like we did in production. And for this one, we're using Loadstorm, which is a tool that basically spins up a whole bunch of cloud clients and hits the website. So you can see here, after 5 minutes of running the tests, we get this big, massive drop where basically the website was unresponsive. Okay, so a big flat line where it basically wasn't serving any pages. So that's good, because we found that there was an issue, and then we can start looking at what's causing these issues. So profiling, looking at the hardware, and that sort of thing. So we went on for about like a week looking into these issues, but obviously rerunning these tests as we go. But no matter what we did, we kept hitting that same 5-minute mark where nothing would respond. Okay, so we suspected it's got something to do with the hardware and hosting, because like after all these code changes we did, nothing changed in terms of that load test. So what we decided to do was we simplified the load tests. Instead of like searching for products, adding stuff to the shopping cart, we just simplified it all the way down to pulling one single image from the web server, so that there's no database calls, no .NET running, it's just serving an image from IIS. And we get the same problem. So we log onto the IIS server and see what's actually happening as the load test is running. Monitor the CPU, start performance monitors, look at the stats for like number of users, sessions, throughput. But hit the 5-minute mark on that single image test, still fails. So at that point, through the performance monitor, we saw that IIS wasn't actually getting any requests coming through. So no users, no sessions, no throughput. Okay, that same 5-minute mark there. So what do you think the cause was? Justin? Not quite, close. Any other guesses? It wouldn't be a connection pool issue because there's no database connections or anything. It's just simply serving a static image from the web server. So the cause of this was DDoS protection on the web server. So we get this nice email back from the hosting provider that they've got standard DOS protection policies on all their servers. And basically once it hits 1,000 sessions, that kicks in and just stops all requests. So we're hitting that. So yeah, there's a lot of that during this whole process. All right, so figured out the problem, reran the load test after getting them to turn off that DDoS protection. This time, instead of failing within 5 minutes, we're getting to 40 minutes. So we're making some progress. So we log another ticket with the host. Again, this is just serving that single image, so there's sort of no reason why it shouldn't be handling that sort of traffic. So we log another ticket with the host. So here's my email to the hosting provider, basically the same sort of thing, 40 minutes into the test, we're getting a network timeout. Pings to the server still go through, server's idle, sort of the same sort of behavior that we were getting before. So what do you think the issue is this time? Any guesses? Yeah. Well, I should have mentioned that this is running in a virtualized environment. So there's one host running several VMs. So the problem here was CPU contention. So there was too many VMs running on that host. Now this stuff is sort of invisible to us. Like no matter what sort of performance stats we run on the physical machines, sorry, not on the physical, on the virtual machines, we can't sort of see what's happening to the other virtual machines. All we're seeing is like, this CPU on our server is not doing anything, whereas one of the other virtual machines might be hogging all the CPU and causing these sort of problems. So we got them to basically create another host, migrate some of those virtual machines off so that we can have sort of one dedicated host for our database and web servers. More face palming at this point. All right, so cool. Now we're able to run our test to completion. We ran it for a full hour, but we get this funny business in the middle here. So the green line is users from our load test. We're sort of getting a flat line here. Our web server is still sort of responding. What do you think happened here? Well, no, it sort of picked up again down here. It sort of started serving requests. No, for this one, remember this is a cloud-based load testing suite. So our other dependency on this is this one was running through Amazon Web Services. So there was actually an Amazon outage on EC2 during that period. So yeah. All right, so once we figured that out, this is actually how the test ran. So it's like this beautiful graph where as the user load scales up, we can see our web server is keeping up in terms of the number of requests being served. So that's great, that's beautiful. That's actually what we want to see in these sort of performance graphs. You don't want to have those sort of spikes or any sort of flatlining. All right, so now that we've figured out that the hardware is not the issue, we can now redo the tests with running getting items on our shopping cart and sort of running through that checkout process. Okay, so we search for a bunch of products, add 10 things to the shopping cart, go through a checkout process, run the tests. Oh, this time we're getting to this 10-minute mark before the web server starts failing. Okay, so again, we log onto the servers, sort of just check what's going on. CPU and RAM were good on the database and IIS server, but we still aren't getting any pages being served. So we had a look at the resource monitor, and we noticed this figure here, 146 megabits per second getting transferred across the network. So this is, I guess, between the database server and the web server. Now, so we did a manual file copy to our servers. So we're only getting this 10 megabytes per second. So what do you guess is the connection between the database server and the web server?
10.
Not 10. 10 will get 2 megs a sec, 100 megabits. So we're actually saturating that network interface. Now, we didn't think this was a problem because when we asked the hosting provider to provision the network, we asked for gigabit connections. So more face palming. So network saturation was the issue. So this is sort of another symptom where if you see like nothing's happening in terms of CPU and RAM, it could be network contention. Okay, so we got them to fix up that network to gigabit, and that sort of fixed that problem. But that being said, 146 or 10 megabytes per second is still a hell of a lot of data being transferred between the web and the SQL Server. So that is actually still a problem that we need to investigate and sort of figure out what is causing that chatter. All right, so back in business. So now we can start identifying our bottleneck. So we know our infrastructure is good. We sort of went through all that rigmarole to make sure that the infrastructure is not our problem, not the problem. So what do we do to find where our application is slow? So you can identify bottlenecks just by simple user feedback. Users will be very vocal in terms of what is slow in your application. So you should always take that feedback. You can actively monitor by using Glimpse. So who's used Glimpse before? A couple of guys? Yep. So Glimpse basically gives you statistics as the page loads to see what sort of assets, what MVC or what .NET's running in the background, what SQL Server's running, and sort of all the rendering stuff that's happening behind the scenes. IntelliTrace is also another good one. Who uses IntelliTrace? No one? Yes, it is only part of the Ultimate Edition for Visual Studio. And then application performance management tools as well. So let me just quickly show you, and profiling tools, which I'll talk about later. I'll quickly go through Glimpse. Glimpse is really easy. If you're running any sort of .NET web app, you just install the NuGet package called Glimpse, hit F5 on your application, navigate to glimpse.axd, click on the little G icon down the bottom right. Okay, so this is what it looks like. Glimpse.axd, you hit turn on Glimpse. You get this little G down the bottom over here. And it starts giving you these nice stats down the bottom. You can expand it, it gives you a timeline. So let's see if I can, not sure if you can see it, but it tells you exactly what's happening in that whole pipeline. So it's calling the home index, it's rendering. You can also add additional tabs as well to see what's happening in terms of caching, SQL Server calls, that sort of thing. So it's a really good tool just to sort of see, I'm hitting this page, what's actually happening. Okay, and then there's the Ajax view as well that gives you how long the Ajax calls are taking. Particularly useful if you're using like Angular applications. Okay, IntelliTrace. So IntelliTrace is actually pretty good if you've got Ultimate, good way to eyeball. You get it in 2015 out of the box by just hitting F5. You get these diagnostic tools. It starts listing all the events that happen over here. So you can see it appears into like the SQL queries that are being run. You can see the CPU usage up here. There's RAM usage over here. So it's a really good way to eyeball what's going on. So it's actually quite good if you hit a page and then you can see all the SQL requests that are happening. And that's one of the tools that we sort of use to figure out what was being chatty in that application. Okay, the IntelliTrace also gives you, when you put breakpoints in, like how much time has elapsed from your last breakpoint when you're stepping through code. So it's a nice way to give you sort of these performance statistics when you're manually going through code. Okay, these are APM tools. This one is New Relic. So it's a little like, I guess, a little exe that you install on your server. If you're running Azure, you can just get these as add-ons to run, and you put a little bit of code in your web config, and then it starts collecting all these statistics about your web server, what sort of requests are happening, and basically for these tools, you get live statistics, and what you're aiming to do is like look at these spikes and then sort of drilling in to see what is actually rendering slow. Okay, so in this one I can see that viewing some report took 2.5 seconds. So we can start drilling in and sort of identifying these pages as being slow and needing to be optimized. Okay, these tools are pretty good as well, because they give you like alerts by email if anything happens. Okay, Microsoft have their own APM tool called App Insights. So again, you're investigating these spikes in the server performance and just having a look down here to see what's going on, what requests are being slow. Okay, we've got a rules page on how to set up App Insights. Who's using APM tools in their applications? Just Justin, Duncan, a couple of guys. I highly suggest that you do invest in these. A lot of them have a free tier where they collect the statistics, but they hold it for like a short amount of time. So I think New Relic keeps stats for 3 days. So it's really good just to see what's happening. Okay, Raygun have a useful tool called Pulse that gives you more user tracking, but they give you sort of the median load time, average load time, that sort of thing. So it's pretty good to see. Okay, so those sort of tools give you sort of the big picture and let you know where you need to start drilling into in terms of your stack, whether it be SQL queries that you need to have a look at, or your .NET code, or even if it's the front end that needs optimizing. So let's jump into optimizing SQL Server. So one of the easiest ways to optimize SQL Server is just to simply run the SQL profiler. You can use the duration template because that orders all the queries that happen from shortest to longest. And you basically scroll down and just tackle all the ones that are down the bottom. Okay, so when you do fire up profiler, there's a whole bunch of templates you choose. So I recommend choosing the duration one. And you can analyze the results. So I've got one prepared from earlier over here on one of the apps that I've been working on for a client. So you can see down the bottom, if I scroll up, like there's a whole bunch of stuff that's happening, a whole bunch of select statements that are basically returning instantly, which is good. Okay, a bunch of smaller ones, but then you scroll down, you get to sort of these heavier ones down here. So as my general rule of thumb, I like to try and optimize all of these queries to be under 100 milliseconds where possible. Okay, so basically you can click into these, grab the SQL query, like you can, if it's not a store proc, you can actually see the query that's being run, like copy that into SQL Management Studio and sort of identify what's going on. So let me just do that now against one of my databases. Let's get rid of all of that. And some of the most useful tools built into Management Studio are these execution plans and client statistics up here. Okay, so these two little buttons up here. But let me just stop it and I will just execute it a few times first, just so you can see the performance. So you can see there down the bottom, about a second to execute that. Run it again. It's pretty consistently at that sort of 1 second mark. If I go down to client statistics, you can actually see all the sort of timings and how much data is being sent to and from the servers, sort of what's going on in terms of inserts, updates, and deletes. But the key figure we're looking for is this one here. So you can see this one is roughly 1 to 1.5 seconds to execute. So now that we've identified that this is being potentially needing to be optimized, we can turn on the execution plan up here. So there's estimated execution plan and actual. I'll turn on the actual one. Now the execution plan breaks down exactly how SQL Server is breaking apart this stored procedure and running the query. Okay, so you can see that this particular query is made up of a whole bunch of smaller queries, like so. Okay, and you're basically trying to look for the one that has the most time. So 38% of the time of this query is spent in this little statement in here. Okay, and I think I've actually run the performance tuning on this one already because it's not suggesting the indexes, but I think I've got the screenshot for it. Okay, so we drill in, run it manually through SQL Management Studio, look at the execution plan and client statistics. The key things from the execution plans you want to look at is how indexes are being used, whether it's oops, this was my big one. Let me try and resize this. You want to scroll across and just look at which component takes up the biggest percentage. Okay, so you can see here this index delete is taking up the biggest percentage. Here, SQL Server breaks down sort of what it's trying to do in terms of how much it's executing, how much CPU time it's taking, and that sort of thing. But the things that I generally look out for is where it's doing a scan rather than a seek, because scan basically means it needs to individually go one by one, whereas a seek means it can jump straight to that row. And the other key statistic that I look for is the estimated number of rows versus the actual number of rows. So for this particular one, they're in sync, 717 for estimated and 717 for actual. Okay, because when they're out of whack, SQL Server performs slower. Okay, and generally for these queries, you can add a lot of speed to them just simply by adding an index. So what an index does is gives SQL a hint to say, okay, this particular table gets queried by these columns a lot. So SQL Server will then create an index. Think of an index like a dictionary or a table of contents. So when the query runs, it can quickly look up that table of contents to see, all right, the data roughly sits in this section of my database, and they can just pull those records rather than having to scan the table one by one to try and find it. Okay, and the other way to speed it up is to actually rewrite the query. Sometimes the queries are just bad. Okay, so when you start tuning SQL Server, it's important that you stop or clear out all the cache that SQL Server has in it. SQL Server is very good at trying to optimize itself in terms of caching a lot of the things and keeping statistics up to date. Statistics are more like when this table gets accessed and these things get queried, roughly the size of the data that gets returned is X. So it keeps that in its own memory, just so the next time it can say, okay, someone's querying the same thing, I can allocate this amount of memory straight up without trying to actually get the number of rows and allocate it. Now, this becomes a problem where the statistics get out of sync, because if you've estimated number of rows is low, so say you estimate that this query is going to return 10 rows, but in fact it's going to return 100,000, then query needs to say, okay, I've run out of memory that I've allocated, let me grab some more so I can fill in the rest of the data. So that's where it can slow down. So when you run through the execution plans, often they give you these index hints, like up here. So you can just right-click that and see what the index is for that. And let me just grab one, because I think I've got an index prepared. Earlier, and hopefully see a performance improvement on this. I've already got it. Let me drop them. All right, I should actually rerun that so that you can see all the suggestions that it gives you. There we go. So you can right-click that and say missing index details, and basically say, all right, so for this particular table, The status field gets queried, and we're often returning the ID. So let's include the ID along with in the index. What the include means is, so if you think back to the table of contents, and what I said earlier about you have to look up the table of contents, and then that tells you where the physical data is. When you include particular columns, these columns get stored with that table of contents. So all you need to do is just look at the table of contents. You don't actually need to go and physically fetch the data. So that's what the includes do. Now you need to be wary of this as well, in that you don't include too many things, because if you do that, your indexes are going to grow bigger and bigger. And that does have a performance impact as well. But if I scroll down, there's a few index hints over here. So there's another one there. It gives you the impact as well. So if I add this index, it's going to increase performance by about 15%, and that sort of thing, 78%, so that's a big one. Okay. So you go ahead and add those indexes. Let me just go back and add. I should have ran I'll turn off the execution plan and rerun the client statistics a few times. All right, cool. So was it 1.6 seconds, 1.2 seconds? Okay, so then we can add those indexes back in to speed up this query. Okay, so if I rerun this test, I'll run it a few times. Oh, look at that, 0 seconds. So run a few times. So then when you look back at the client statistics, you can actually see the performance improvement. So it went down from over a second to about 200 milliseconds just by adding those indexes. Oops. Duplicate. All right, so you can measure the performance impact using the client statistics, and you can use the execution plans to give you sort of hints as to how you can optimize the queries. Sometimes there's no indexes you can have, and you just have to rewrite the query to be better. Okay, so the execution plans sort of tells you roughly where the bottlenecks are. Those arrows that link all the different components sort of tell you how much data is flowing between the different components as well. So you should actually look for where those pipes are really fat, because that means a lot of data is being transferred between those components. And maybe one way of speeding it up is to actually reduce those number of rows that it has to process early on. Okay, and there's a whole bunch of warnings as well that the execution plans will give you, which let me just see if I can get it. Basically, you look for exclamation marks, and they'll sort of tell you what's sort of bad. So this one, nested. So this one's using a join, but the joins don't have a predicate, meaning that there's no sort of foreign key relationship. It has to actually figure out that join manually. Yeah, so these are the sort of warnings you need to look for as well in your execution plans. Now, analyzing execution plans is like a whole user group session on its own. So what I recommend you do is to have a look at these resources on understanding execution plans. The second one is particularly good. And it just walks you through what you need to look for. Okay, so it gives you the full execution plan, gives you a couple of sample queries. Sort of this is like a massive, massive execution plan that it needs to generate because of the number of parameters that are being passed in. Okay, so it goes through a few examples of optimizing the execution plan. So definitely check this out. It's a great resource. So other things to look out for as well when you're tuning the database is, like I said earlier, there's an excessive number of calls between your web server and your database server. So you need to figure out what's causing all those extra calls. And I'll talk about that when we jump into the optimizing .NET side of things. So for this particular client, when we ran the profiler and we hit the search page and like search for something, it would actually make 300 SQL calls to return that page of data. And you can probably figure out why it would do that. So if you're returning a search page that maybe returns 50 items, maybe it needs to do additional queries to look up other properties of that particular product that's in a separate table, maybe. They should use joins, but maybe it's not. It's a third-party product, so we don't know what's actually happening. You should also look out for stuff that doesn't make sense. So again, on this search page example, it actually triggered one insert and one update whenever someone did a search. And that actually makes no sense at all. You're doing a search, you should just actually be querying the database for results. Potentially, it might be doing something, trying to do something smart in terms of like adding the search term to some sort of cache so that the next time when a user hits that, then it can just grab that cache data, maybe. But there are better ways of doing that. Basically, anything that's sort of like read, that you can get away with being read-only, you should. Yeah, so basically this stuff was the cause of our bandwidth issues early on when we were running the load tests. One other one that's sort of a bit harder to diagnose is parameter sniffing. So who's heard of parameter sniffing? You want to give us a brief explanation, Justin?
Basically, when you execute a store proc and every time you pass in a dynamic parameter, SQL Server is trying to optimize it and say, oh, well, this is the best way to get it, but sometimes the parameters change types, or some are blank, some are null, and then it will totally change the query plan.
Yep.
And that can suddenly go from working awesome to not working awesome overnight.
Yep.
And sometimes you can restart a server, it's perfectly fine, and 3 days later it's not.
Yep. Yeah, so as Justin said, so parameter sniffing is all about these extra parameters that we pass into queries or stored procedures. And essentially what happens is that SQL Server needs to generate an execution plan, a query plan on how it's going to execute that stored procedure. So what it tries to do, and it tries to be smart, is that when it sees a parameter and it's returning, say, 1,000 results, then it sort of says, all right, so whenever I get this, it's an integer, we're always going to get roughly 1,000 results. So you might run this a few times and it's roughly always that amount. But every so often you might get one particular parameter, like 15 for example, that instead of returning results in the thousands range, it might return results in the hundreds of thousands range. And that's where you get the big performance hit. And I guess this one's sort of like really hard to diagnose because execution plans, unless you like really know how to analyze the execution plans just by eyeballing it, it sort of won't tell you that in an obvious way. And the other problem with this and why it's hard to diagnose is that it's very dependent on how your users are using the database. Because if they're sort of month to month always querying this, but maybe at the end of the financial year they're running this other query that's returning a lot more results and that's running slow, you might not always be able to reproduce it in your own testing or local environment. So it's hard to diagnose.
I'll give you another example. We had a very similar problem with this where we had a massive large table and it had data in it. There was obviously varchar string, but the first few data values all began with a number. So it was thinking, it was optimized for a number. It's kind of like when you copy and paste the data to Excel, the numbers are on the left-hand side, the text is on the right-hand side of the same column, and you've got to format the column to be text so it all lines up and it's all treated exactly the same way for sorting orders and stuff like that. SQL Server does something very similar to that too. So I've had views that are selecting from a varchar table column and coming back saying you're returning an integer from a view which is just selecting from the table. And it's because it was trying to work out what that type was.
Yep. Yeah, basically, like, it's not SQL's fault. It's trying to be smart because, like, in the majority case, that execution plan is fine. It's just for this niche little parameter or parameter value that the plan doesn't work. So there's a couple of things you can do about it. One is you can clear the cache, like I showed you earlier with that dbcc command, and just let it sort of rework itself. But the problem will come back because if month to month they're running like parameters like the first one where they're returning very few results, you're going to hit that problem again when you run a parameter that returns a large data set. So some of the other things you can do is you can give optimization hints in your query to say basically optimize this parameter for being an integer or optimize it for being a certain number even. Or what you can actually do as well is to say don't create an execution plan for it at all. If you know that your data is actually going to be very different depending on the parameters. It's not always going to be this uniform size that gets returned. You can actually tell SQL Server to just not bother generating or caching a query plan for it and just always work it out. And sometimes that's actually faster than doing it. It's a bit more CPU intensive when it needs to generate those execution plans. So to learn more about parameter sniffing, I recommend checking these sites. It goes through like in detail about what SQL Server is doing, why these scenarios occur, and sort of what you can do to, why didn't that load? Oh, I think that didn't actually go to the right one, parameter sniffing. You can go to the links after. I've got a link that you can access. But yeah, definitely check out those ones because these ones are sort of, you'll hit these in production environments more often than not rather than in your development environments. Okay, the other thing to worry about in terms of SQL Server performance is indexes and how indexes are being used. So I said earlier that you can speed up queries by adding indexes, but there's also drawbacks to adding too many indexes because when you add an index, it slows down your inserts, your updates, your deletes because it needs to maintain that index. So when you add a new row, it needs to say add this new entry in, to your index to say, okay, it belongs roughly in this section here. So don't go overboard in adding indexes. You sort of need to just figure out the right balance. And SQL Server has a whole bunch of views, which if you click on these links, it walks you through all the queries that you can run just to analyze the indexes, how often they're actually being used, and so that they're good candidates for actually dropping if they're not being used very frequently. Because sometimes when you're looking at performance, it might be all right that a report that gets run once a month might take 2-3 seconds to run. You don't want to add an index just to optimize that one report that gets run once a month and sacrifice the performance of your overall application for day-to-day usage. Okay, the other important thing you can do is simulate live traffic on your application. So you can run the SQL profiler and use the what template was it? The tracing template or something. Is one of the default options. And basically start capturing traffic during a period where you've got typical uses of your website. Because once you've captured that, you can pipe it through the database tuning advisor. And that is basically automates all that stuff I was talking to you about earlier in terms of recommending indexes, keeping statistics up to date, that sort of thing. So here's that same trace file that I ran through the database tuning advisor. So it's suggested that I add a whole bunch of, these ones are mostly statistics. So again, database statistics are basically like how big are these columns, how much memory do I need to allocate for these columns, how many rows, if they're querying by these columns, am I going to return, that sort of thing. So if I apply all these, it estimates that I'm going to improve my overall performance by 86%. So you sort of get this free performance hit if you apply all these. Okay, you can also drill down because there's more reports that you can get when you run this tuning advisor as well. So all those index, the index usage ones. So over here, there's a whole bunch of reports that you get access to. So index usage report. Okay, so these were all the indexes that were hit while I was capturing this trace. So I only ran this for like 2 minutes. You'll more likely run this for hours in your application. But yeah, it gives you a nice snapshot of what tables are being accessed, what would most benefit from adding an index, that sort of thing. What else have we got here? Yeah, size of the index, how many rows are in the index, that sort of thing. So these ones are sort of trying to highlight candidates are being deleted. Basically, there's a whole bunch of options that you can choose when you're doing this for what sort of suggestions that the tuning advisor will give you. So yeah, definitely run this once your site is live and running and you've got users using it, because you can get a lot of performance improvements out of the box from this. Okay, so to summarize, when optimizing SQL, SQL Profile is basically your go-to tool. To fix it, look at the execution plans and run it through database tuning advisors. But basically, you'll be adding indexes or rewriting queries for the most part. There is a whole sort of configuration side of SQL Server in terms of performance that I'm not going to sort of talk on, but there's that side of things as well that you can look at. Because sometimes SQL Server, people can misconfigure it and just do bad practices like put log files in the databases on the same physical drives, and that would sort of impact on performance. And also doing index fill percentages and all that sort of thing, and also database growth as well. But that's for a session on its own. Okay, so when optimizing queries, some of the big takeaways you should do is select only the columns that you need. So back when we're looking at the client statistics, one of the other columns besides the duration one that you should look at is the number of bytes returned from the server, bytes received from server, and just make sure that that's not too much. Okay, and one of the big culprits of that being fairly large is doing a select star on your queries. Okay, so I see that a lot. Using joins effectively, so instead of doing sub-selects or we're doing like where in and then doing a select, to see if you can do a join. Because if you do a join, it more likely than not, you can use an index and speed up the query that way. Avoid cursors if you can, because SQL Server is good at set operations. It's not sort of good at that procedural sort of one step at a time thing. So sometimes, instead of like doing this sort of like the for loops inside of SQL, sometimes it's better to just return the whole data set to your .NET code and let .NET do that for loop instead, in terms of like if it has to do some complicated calculation. Watch out for parameter sniffing, and keep your database statistics up to date, because the database statistics is what SQL Server uses to optimize itself. So if it's out of date, it's going to give you bad performance. Okay, other tips are to denormalize very heavily accessed tables. Now, as developers or database guys, you want to design your databases like in a good way in terms of having that good separation, like tables with foreign keys that you'll then use joins to pull all the data across. But sometimes you end up writing a query that maybe joins 10 tables together. That means SQL Server has to look up data across 10 tables to put together your query. So that can sometimes cause performance impact as well. So sometimes you have to denormalize your tables to get the performance improvement. So move all the data into columns in your main table. Or another way of doing it is to create index views of that data. Okay, more RAM always helps. If you can get your whole database loaded into RAM, then you're pretty much getting the full performance out of your hardware. Separate physical drives for data and logs. So back to the client. So after we went through the optimization for SQL, we started getting this sort of nice looking graph. There are still a few like peaks and that sort of thing. You want to see it like more closer to the user line if possible, but we're getting a respectable 88 requests per second after getting to, what's that, 2,500 users. So that's quite respectable. Okay, so then we've got the whole .NET side of things to look at as well. So finding bottlenecks in .NET, you've got your profiling tools. So Redgate has Ants Profiler, Telerik has Just Trace, Microsoft have their own built-in performance wizard. I tend to prefer like these third-party ones simply because there's a nicer user interface and they're really good at surfacing where all the problems are. But you can, if you don't want to do profiling, you can also use these application performance management tools as well, and just look for those spikes and drill in, because they often break down on exactly what's happening on your server. Okay, so like New Relic, App Insights, Stackify is another one as well. I'll quickly run through this. I won't demo this, but you basically run your profiling tool. It'll give you statistics on CPU usage, memory usage. Typically, you can drag for a timeline and just look at that particular area and see all the calls that are happening in there. Most of these tools have these, sort of hotspot and bottleneck areas that you can just click to, and it just surfaces the ones that take the most time. So I can see it here, it's running some sort of enumeration, and it's taking 10 seconds to run, so that's really slow. We need to drill into that and see what's going on there. And more often than not, these profiling tools also will log the SQL calls as well. Okay, so you can drill in to say, okay, so this one also took about 10 seconds to run. Other nice things that they give you is how many times that query is being run. So if you've got, this one's a bad one, but if you've got this query taking 3 seconds being run 2,000 times, that is really slow. For something that gets hit that often, you want to optimize that down to like less than 100 milliseconds. Okay, so this is also a good tool to try and identify where all the bottlenecks are. But then again, you need to sort of look at, is it some of my code that I'm writing that is generating these SQL statements? All right, so link to entities. Who uses link to entities? Pretty much everyone should be using link to entities if you're not doing Angular development. Link to entities is one of the biggest culprits to poor performance. So I'll give you this as an example. So I've got this for loop. Oops. So I've got this for loop over here. Let's try and fit that to the page. So it connects to a table called obligations. I loop through, the obligations have a whole bunch of members, and then I'm just printing out the group name and an ID, and concatenating that into a string. Okay, I'll run that, return my results. Oops, what did I break? Oh, sorry, I need to switch that. 1 sec, let me just fix up. Probably made a typo here. M is obligation group members. Okay, that worked. So prints out a whole bunch of statements. This particular query is fairly quick, but can you guess what's actually happening under the covers? I want to have a stab at what SQL gets generated when you write this. One statement? Anyone? One statement? Two? Two statements? We're accessing two tables here? No. It's actually really, really bad. So if I pop over into the SQL, scroll to the top. All right, so we're doing basically selecting everything from the obligation table. It's just listing out all the columns, but that's a select star from obligations. So I guess that's that line there. And then for each of them, so I guess this is the IDs that it's returning. So it then selects everything from the obligation group. So that's that table there. And then for that, it's then selecting everything from the group members. And then it's going through each group member. So you can see these IDs are changing, and it's basically, for almost every row, it's generating a select statement. So that's terrible. So if I actually have a lot of members, so if I have 1,000 members, this is going to generate more than 1,000 SQL statements. That's really bad. But you can't tell from the query that it's going to do that, because link sort of hides away all of this stuff. And this is where, like, I guess all that database chatter happens in that the shopping cart application. It's like queries like this, where it's really easy for the developer just to type this. It makes sense logically. I'm looping through, just grabbing these things. So to fix that, I hope this keeps me on the same page. Nope. Let's quickly speed through this. Yeah, so as a developer, it's like really easy to write those for loops rather than having to think in terms of SQL. So to do this properly, yeah, so it generates really nasty SQL. And if you write more complicated stuff that accesses more tables, it generates like this really, really massive statement. And the problems with those massive statements is that SQL Server then needs to try and generate an execution plan for it, which takes some time. And that's why sometimes when you're doing these link queries, you get this like delay on the first time you hit a particular query, and then the next time it's fast because it caches it. But loops and then queries is something that you should always look out for. Now, and the select star that it was doing as well. So the proper way to write it is to do something like this, where we physically tell it that all I want are these two columns, group name and entity ID, and I want you to create this new object that has that. And this is how you get group name, this is how you get the entity ID. And then I want to loop through that and then print out the thing I had before. So if I run this, which I've got prepared here, okay, slightly different output, but same sort of idea. It generates nice SQL that you would expect if you were to write this manually, this query manually when you do SQL. So I do a select, and I've got a join to the two tables that I'm accessing data by, and then I'm just selecting those two columns. Okay? So that's what we expect. And by doing this, what's that? Query successful, 100 milliseconds to run that, 300 milliseconds to run the previous one. And obviously, if there's a lot of data, it's going to scale poorly as well. Okay, but problem is, you have to think to write this sometimes. It's much easier just to do a for loop and just get access to your properties. So it's a bit of a problem with link and it's lazy loading. Okay, some of the other things in terms of code is running it in debug mode in production. I've done that a few times. We found when clients have called us up a few times, this is one of the things that we'd first check for. So we've got a tool called Health Check that has this check out of the box, and we run that on our website, which I can show you. So quick sanity check basically, but basically if you have that debug mode on, when code runs, there's a bit more data that it collects as well. So it gives you like line numbers, that sort of stuff that happens. So Health Check is like a free sort of NuGet package that you guys can just add to your application. We've got a few checks out of the box, but checking that debug mode is off is one of them. I think we've got checks on like you can connect to databases and things like that too. Okay, caching is another big one. So cache data that doesn't change too often. So in terms of our shopping site, product descriptions, categories, the menus, product names, that sort of stuff doesn't change. Okay, and if it does change, it's probably okay that if the user doesn't see that change straight away. Unless it's like really bad and you've got like some sort of swear words or something completely wrong. But that's another problem. So why cache? If you cache, you reduce the number of calls to SQL because you've basically got the answers and it's just returning it straight away, bypassing any calls to SQL, any sort of calculation logic. Reduce the CPU if there's complicated logic. And like I said before, it's basically a cheat sheet for your answers. Now, let me just quickly show you the impact of caching. This is a site that I've been working on for PwC. And as you can imagine, it involves a lot of calculation. This is basically calculating a whole bunch of sort of tax percentages here. So there's a whole bunch. When you make a change, let me just quickly fudge a number. Save and close. What this does on the back end, and this has happened now, is that it needs to go through like this. There's a whole bunch of data points and all of this sort of calculation engine that it runs through, but it needs to recalculate all those percentages, and all those percentages are sort of fed into other percentages. It's like very convoluted, very complicated. But you can see that it's roughly taken some time to do the calculation. Now it's reloading all those percentages. And that takes probably about anywhere between 5 to 10 seconds, depending on how complex the user has set up those calculations. So this sort of thing is perfect for caching because it takes a damn long time to calculate. It's still loading. And it will be frustrating for a user that just hits this page and they're just sitting here waiting for this, like I am now, and now it returns. So that was probably 20 seconds, maybe even 30. So all these calculations are static until someone goes in and changes one of those numbers that I showed you before. So caching, if I just refresh the page now, gives you all those calculations straight away. You don't have to wait for that to recalculate. And so you should try and identify areas of your application where that data can be stale or that data doesn't change. And those are really good candidates for caching. Okay, but when you do cache, you also have to worry about expiring it and sort of managing it. All right. The other thing you can do is output caching as well. So output caching just caches like the HTML that gets rendered, that gets generated. Okay, all you have to do for that is just add the output cache attribute to your NVC actions. So I won't go through that. Data structures, so most of the time we'll be using lists, which if you need to search for anything in the list, it'll be run in order n time, linear time. So if you're doing like a lookup by code, for example, it's much better to create a dictionary. And LINQ has a built-in method called toDictionary. Does anyone know about that already? Yep. That generates that hash table for you. So if you do that, again, it's very similar to the SQL indexes. It's got ABC on the table of contents, and it can just grab that data straight away rather than having to go one by one through the list. So just be smart about how your data is getting accessed. Okay, so for our client, one of the slow bits of the page was the search for the products. So if you search for the product red, as a keyword red, we had to check that red was in the product name, it was in the description, it was in any attributes like the color, the brand, the category. So there's all these tables that we had that the third-party engine was querying. So if you were to manually write the SQL, it would basically look something like these with a whole bunch of these outer joins and these OR statements to check whether that term was in there. So that's already bad straight away because as soon as you're using any sort of OR statements, you're throwing away any indexes. SQL can't use indexes to help you with that. So to improve the search, you could use SQL full text indexes, but you still need to do stuff like this. The full text indexes does give you some nice abilities, like being able to search within a big blob of text, or doing stuff like ignoring plurals, or doing stuff like words that sound like other words. So it's really good at that sort of stuff. But for this particular database for the client, we'll still need to sort of query across those different tables. So what we ended up doing was we used Lucene. So anyone heard of Lucene, used Lucene? Great. So Lucene is basically a document database. It was ported from the Java guys, as with most great .NET technologies. We steal it from the Java guys. And basically what it does is you define a document and you define all the ways that you can query the document. And it's similar to what it's talked about earlier with SQL indexes, where you can make it include certain columns as well. So what we did with this particular one was, okay, so we identified the fields that we wanted to be searchable. So we added that to the Lucene index, but we also identified what fields that we just wanted to store the data, so it didn't need to do a database lookup as well. So for the search page, which is like the big sort of icons and just the product name, so we stored the product name. What else did we store? We stored the price. I think we stored the image URL and the product code. So we stored those 4 things along with the document. So what that means is when they search up red, it searches up the Lucene index, it looks up its own sort of engine, and it doesn't have to go back to SQL Server to look up the additional data because I'm storing those 4 things that I'm displaying on that search grid there already. So check out these pages on sort of what you can do with Lucene.net, and sort of there's a benchmark there as well. And the other cool thing about Lucene as well is that there's another bolt-on to Solar that gives you a free REST API on top of your search index. So you can query your indexes using REST, which is pretty cool. So other coding things, which I won't go into too much, is like using parallel and using async await. Basically, that's if you need to access anything blocking, you should use the async so that it can sort of continue. And just stop when it actually needs to get that data. Okay, other things is to keep up to date with the latest framework. So if you're moving from .NET 4 to 4.5, you get a free 30% performance improvement on startup and 30% lower memory usage. Or if you move to ASP.NET Core, .NET Core is like super lightweight, super quick, and There's a post here on it reaching 15 million requests per second. It's super duper quick. So I'll go to that and you can sort of see where .NET, the full .NET framework sits in terms of that graph. All right, so there's .NET Core on Windows and Linux. You've got ASP.NET Full over here, down there, all the way down the bottom. Okay, so if you're doing a greenfield development, I would suggest you use Core, but there's some drawbacks to using .NET Core as well, because not all of your favorite packages are going to be ported over to the .NET Core framework. Okay, so for optimizing the shopping site, we added cache as well, which helped improve those pages. So when you clicked in on the search page to a particular product, we cache those products because the more popular products will get hit a lot. So just cache it and get that served straight away. Cache the products in their shopping cart. But basically, we went from the search taking somewhere between 300 to half a second, 300 milliseconds to 500 milliseconds, 300 reads, 1 insert, 1 update, to 28 milliseconds, 0 database calls. So that basically took away a whole bunch of load from SQL Server. So SQL Server could do other things and like actually do the important stuff, like making sure people can actually go through that checkout process rather than spending their time searching up products. All right, cool. So that's the .NET side of things. Now, how are we doing for time? Okay, front end. Front end, there's a whole lot you can do on front end because the front end is all about after your server's rendered the page, how long it takes to get to the user. So it's all about reducing that time or reducing that appearance of that loading time. So the key things you want to do here is reduce the number of requests, move static images, JavaScript, those sort of assets to a CDN, because most browsers have a limitation on number of requests per domain. Reduce the size of files, so image files in particular, JavaScript and CSS, if you can sort of squish it up, remove all the comments, remove all the white space, that'll make it quicker. Gzipping as well, enabling gzip can reduce the size of files. Cache everything you can, so JavaScript, CSS, images, they're pretty good candidates for caching. Use AJAX calls to fetch data dynamically, so instead of having to refresh the whole page, you just refresh this little chunk of this little widget on your page. Okay, so if you do Angular, that's basically all you do. Okay, so to find the bottlenecks on the front end, Google has the page speeds built in. You can get Y-slow for Firefox, or you can run it through like cloud services like Pingdom as well, and that will give you the breakdown. So for this particular client, when we ran it, we got a page score of 60 out of 100. You can see all the suggestions that they give you. When we ran it through Y-slow, we got a grade C, so we got 75 out of 100. So we went through the process of going through and optimizing, trying to get as many A's over here as we can. Okay, so for page speed, we ended up getting 91 out of 100, which is pretty good. On Y-slow, we got an A grade, got 90, which is pretty good. One thing we didn't really have control over was HTTP requests and minifying some of the assets. Because we're using that third-party e-commerce sort of framework, we're sort of limited in like how much we could actually do on that side. But getting an A and 90 plus is pretty respectable. Okay, so I didn't go into like what we actually did to get those grades, but Mads has a really good video from TechEd, and he walks through all the things that you can do on IIS in your code in terms of doing bundling and minification. So it's about an hour-long video. It's really good. Just goes through all the things that I just sort of summarized there. All right, so lessons learned. Where did we end up? So for this particular client, we pretty much met their expectations. We hit the 4,000 users. We've got this nice, lovely graph that sort of is within sort of that, in line with the user growth. We do have these like little spikes here and there, but that's not too bad. You're not getting like big sort of spikes. So performance-wise, SQL Server was humming along because basically we took away a lot of the load. there was about 10% CPU utilization for that, for those 4,000 to 5,000 users. The web server was running a little bit hot. Okay, it was running at about 80% CPU, but it was still handling that load. But if we wanted to scale further for like 5,000, 6,000, then we might run into a bottleneck for CPU. So talking about bottlenecks, so in your application architecture, this is sort of roughly how it would look. You've got the SQL backend, you've got your web server that runs IIS, that has your business logic and your front end. It connects to your service provider and provides all the assets to the end user. So in terms of performance, any one of these components could be bad. You could have something dodgy in your SQL Server in terms of bad queries, bad configuration, that sort of thing. Some of your code could be running poorly. Like I said, if you're using for loops and link queries, you can have excessive chatter. Your front end could be designed poorly. It could be all your images, your assets are too large. It's taking a lot of bandwidth to send across to the client. You could be making too many requests, so things are sort of blocking. The issue we had where there was basically a problem with the connection between SQL Server and our web server, that 100 megabit to gigabit conversion, as well as that chatter that we basically eliminated. The connection between the web server to the internet could be bad as well. So we had a client that had an intranet site. They had users that wanted to access it from home that were complaining that it was really slow. But when they were in the office, it was like really quick, intranet app, obviously. So the problem was basically that in their office, they only had I think it was like either 1 megabit or 2 megabit uplink. So realistically, they could only serve pages at like 500 kilobytes per second. So that was cause of the slowness there for their users. It was just bandwidth, pure bandwidth from the web server to the internet. Connection to the end user as well. So your server could be geographically far away from your end users. So you might have servers in the US, but your user base is in Australia, for example. So you should have local servers as you can. Now, I haven't talked about anything in terms of like multiple servers in different locations, that sort of thing. But that's another thing you can look at, having your servers as close to the end user as you can. Now, one of the other ones is your hosting environment as well. So that caused us a hell of a lot of pain, and it's happened not just on this client, but other clients as well. Because a lot of that stuff is hidden from you. So you should also just do a sanity check that your hardware is actually good as well before you start doing performance tuning. So biggest lessons learned was know what your target is. Is it 100 users? Is it 1,000 users? How can we actually be sure that that's the right target? So if you can run some sort of analytics, whether you use Google Analytics, look at the number of active sessions during that big period, or if the site's running live, then you can actually get actual live statistics as well on that period. Have load tests set up and ready to go early in your development cycle. Don't leave it to the very end. Ensure that your infrastructure is good, because you don't always get what you ask for. So we asked for gigabit, we got 100 megabit. And sometimes you can't always see what's happening in virtualized environments as well. Sometimes throwing hardware at the problem is a quick and easy fix. So remember the CPU running at 80% under load? We solved that by just getting the hosting provider to upgrade their CPU architecture. And that just made it basically down to 20%. For the client, there was no additional cost for that because they were in that sort of period where they were renewing their hardware anyway. CPU architecture basically changes every 2 years and you get this phenomenal increase in performance. So just by upgrading the architecture, we basically eliminated all the performance issues all the bottlenecks on the server side. So yeah, sometimes throwing money at hardware is cheaper than throwing money at development to fix your problems. Caching is a big one. Cache everything you can where it makes sense to. This isn't so much of a problem if you're doing sort of MVC Angular development, but back in the old ASP.NET days, session state, view state, They all take up space every time you do a post. So avoid those where you can. Chatty SQL Server. So if you're writing really complicated link queries, look at what the link queries are producing. Can you rewrite the link queries to produce a better statement? If you can't, can you just call a stored procedure to get the same data? Sometimes that's better. This one's a big one. Don't launch the new site when you know it's going to get smashed. Clients love asking for this. We've had a few. It's better if you can get some breathing room, get the site up and running, sort of maybe a month in advance, just so you can make those adjustments and sort of see where all the problems are going to arise. Because you really can't test for everything. You don't know what the users are going to do. Constantly have performance in mind when coding. So running your code, running your load tests so you know when performance changes. Running IntelliTrace, just keeping an eye on sort of if you're executing too many SQL calls, or if you're just running in debug mode and this page is running slow. And just keep it in mind, add it to the backlog as something for you to look at. Now, constantly running load tests is actually quite important because we did pick up an issue with this client. So in the end, we got to about 181 requests per second under load. Something changed on their end. We noticed that it dropped to about 160. And what happened was that the hosting provider installed Shadow Protect on the machine, which I know affected the performance somehow, but at least we knew that this was causing the performance issue, because if we ran the tests, we queried, because we didn't make any code changes that day, but we saw the performance decrease. So we queried the hosting provider to see if anything changed, and they installed something. Okay, so it's important to always have those load tests running so you can see what's causing regressions in performance. So optimizing the database, pretty much everything I went through before. Optimizing software, optimizing the web UI, optimizing hardware. So I didn't talk about load balancers, but load balancers can help as well, because they basically split up your load between multiple web servers, but they can also cache really cache a lot of data, so that they're not actually hitting your web servers. Oh, and also one other thing as well is that you can also get load balancers that have inbuilt hardware for SSL. So that it does all the hard SSL decryption at the load balancer level, so that your web server doesn't have that CPU overhead of having to encrypt and decrypt traffic. Murphy's Law, so if you're with a hosting provider, just query them on, can we upgrade the CPUs? Is it going to cost extra? Because more often than not, it's not going to cost extra, because they're cycling their hardware anyway. More RAM always helps. More CPUs. Basically throw more hardware at the problem. Preventing this sort of thing in the future. So monitoring and being proactive. So like I said, running your load test regularly. If you can run it daily, weekly, at the end of the sprint, or as part of your continuous integration, that will be awesome. So you can use tools like LoadStorm, which is what we use for that client, Loader.io, which is another cloud-based load testing suite, which was done by the guys at SendGrid. Or Azure has its own ones. You get 20,000 free user minutes per month. Azure load test is actually pretty easy to set up. So you just go point it to a test, or you can point it to an existing Microsoft web test. Specify the location, specify the user load, duration, and the browser mix. And you can also add these as part of your build definition as well, as part of your continuous integration workflow. And just have those tests running whenever you check in, or nightly, whenever you need to. So if you're on the Microsoft stack and you're using Azure already, and you're using the release management side of things, sorry, the build management side of things in Visual Studio, then you sort of get all this nice stuff out of the box for load testing. So this is the sort of results you get. So this one was run against Sugar Learning, and we've got Shigami still here? Oh, I ran off. I was going to slag him, because if I ran it for 25 users, we get, all right, pretty good response time, 200 milliseconds. I ran it for 1,000 users, 20-second response time. That's something he needs to look at. All right, so yeah, preventing these sort of things. I definitely, if you're not running some sort of APM tool, get it installed, get it running. Most of them have sort of a free tier. App Insights has a free tier where I think basically it collects, I forget how many events it collects before it sort of stops. New Relic gives you 3 days free of storage, but that's definitely one of the more useful tools out there to analyze sort of overall performance or real-time performance. In Visual Studio, you've got the IntelliTrace diagnostics. You can make performance part of your definition of done. If you've got the APM tools installed, I definitely recommend adding it as something you look at before the Scrum meeting or during the sprint planning meeting, just so you can identify all the issues during the week and just get them added to the backlog so that they're not just hidden and you have to wait till a user reports it to you. Okay, you can also do gated check-ins as well that run the load tests so that it stops check-ins if it causes poor performance. That's pretty drastic. Yeah, so basically remember, performance tuning is a fine art. You can spend days just to improve a few hundred milliseconds of performance. Always measure performance before and after, so you can tell your client, all right, I've improved your performance from 2 seconds down to 100 milliseconds. You're getting value for money. But yeah, weigh up the dollars as well, because yeah, like I said earlier, sometimes it's cheaper just to get more hardware, getting more physical servers to handle the load, getting a load balancer in front, upgrading CPUs, RAM, that sort of thing can oftentimes be a lot cheaper than getting a developer for a week to identify your problems. And the developer might not always be able to fix the problems. All right, cool. So my slides are available there. But stuff for next time, like I can do a deep dive into optimizing the front end, optimizing SQL, and scaling into Azure. So yeah, I'll definitely do those sessions in the future. 2 things, that's my Twitter. Tweet me your favorite tip. And if you don't have the link to the slide deck, if you tweet me, I'll give you the link. And remember to fill out your eval form so that we can draw this $100 JB Hi-Fi voucher. Right, thanks guys.